Now see a Davisson and Germer experiment. This experiment actually demonstrates the particle and wave nature of the moving electrons. It means we can justify de Broglie's concept, or we can demonstrate here the moving electrons behave as wave. Now see the arrangement of this apparatus. First their F is taken, this is the filament made of the actually barium oxide. It is connected to the low tension battery, that is also known as electron gun. This filament is actually used to provide electrons. It emits electrons, and there is here anode here connected to here high voltage, where the voltage can be varied, and from here this has got very small hole, fine hole. So, electron passes through this and gets accelerated because of the voltage. So, we can change the potential difference at A and accelerate the electrons. Now, after coming of this anode, electrons come in the form of the beam. So, we get here electron beam. So, this whole apparatus is known as electron gun, and this is known as electron beam. Now, when this electron beam strikes here on the nickel crystal, it gets diffracted. So, when this electron beam gets diffracted in all directions, by using a detector we find the point here where the intensity of these scattered beam of electron is maximum. So, this when this experiment was performed, actually voltage was taken from 44 to 54 volt, or that is a 68 volt. So, this much voltage were taken. At these voltages this experiment was done, and intensity was found maximum when V was 54 volt and phi is equal to 50 degree. So, at this angle and at this voltage, intensity of the scattered beam was found to be maximum. So, now we will calculate wavelength of these electron by using the wave theory as well as by using the particle nature. So, now see, look, this thing is here. Suppose if theta is the angle between the scattered beam and the plane of the nickel crystal. So, that is a glancing angle, actually this is theta, this is theta. So, we can write theta plus phi is plus theta is equal to 180 degree. So, that is 2 theta plus 50 is equal to 180. So, we can write 2 theta is equal to 130, and then we can write theta is equal to 65 degree. So, this is the value of the theta we have got. Now, for the nickel crystal, the separation between the two atoms, that is D is equal to given to us 0.91 angstrom. Now, according to Bragg's equation, so we can write here, we can remove this part. So, according to Bragg's law, we can write 2d sin theta is equal to lambda. Here 2 into 0.91 into sin 65 is equal to lambda, and when it is calculated it comes out to be lambda is equal to 1.65 angstrom. But by using de Broglie's wavelength concept, lambda is for electron, it is here 12.27 divided by under root of this V. And now, this V is a potential, as I have told you, that is a Davisson and Germer experiment was done at the V is equal to 54 volt, when then intensity was found to be maximum. So, V is equal to 54 volt we can put, and that is coming 12.27 divided by under root of 54, and when you solve it, that comes out to be 1.66 angstrom. So, here we have calculated the wavelength of the radiation by the two ways, by the wave theory concept, by diffraction concept, that is coming to be 12.27 angstrom, and by the particle nature assuming de Broglie's concept, that is coming here 1.66 angstrom. These two wavelengths are approximately equal. So, we can say actually here there is a very close agreement between here these two wavelengths. It means we can say the moving particle behaves as wave.